Hello, everybody, and welcome back to the Grid Shift podcast. I'm your host, Alex Durante. Really quick before we get started today with our guest, we are sponsored by Axis AI. We help companies figure out in a crazy world of AI, we help them figure out how to implement real AI solutions that help them with operations, sales, lead generation, and things of that nature. So make sure you stick around till the end, like and subscribe onto our channels, follow us on our socials. Today, we have a really special guest. Our guest's name is George Roberts. Uh, he's been in this industry for about 30 years doing what I consider what most engineers never learn to do well. And that's taking technology and figuring out how to actually bring it to life. And so George Roberts is the founder and president of TechScale Solutions. They're an engineering consulting firm that helps startups and Fortune 500 companies move hydrogen, fuel cell, and carbon conversion and energy storage, things of that nature. They take those technologies and those prototypes and they actually help you bring them to a commercial product. So before founding TechScale in 2014, George cut his teeth in the engineering world, working for a few different companies. He spent a decade working for one company, driving fuel cell components, and he was the lead engineering as VP at a hydrogen startup company called, I might get this wrong, but I9. George, great to have you on today. How you doing?
Pleasure to be here, Alex. Thanks for having me on.
Absolutely. One thing that I took from our pre-podcast conversation was something you said about being a consultant that stuck with me. And I'm going to quote you here. You said, "My goal as a consultant is really to work myself out of a job and teach them how to fish." And so that's something that really stuck with me. And so if you can, before we dig in too much, just tell us a little bit about you, George, your background, and a little bit more about TechScale Solutions.
Sure. Get started to tell a little bit about how TechScale Solutions came to be. As you mentioned, I worked in kind of a big Fortune 500 company, worked in some startups, and realized there's kind of a balance between the two. The big companies have a lot of formal processes, but move slow. The startups are a little bit more nimble and sometimes take shortcuts and don't always get out the other side because of that. So when I started TechScale in 2014, the goal was really to help companies do the balance of that, do enough development, do it right, do it safely, but also do it efficiently and make sure you're making a product that'll actually, serve the market that you're going after. And, as you mentioned, talking about being a consultant, one of the things I find with a lot of engineers and scientists, I'm an engineer myself, is that engineers and scientists like to make things perfect, continue to iterate, make it better. And they lose sight of the big picture. You can have a product that works great in your lab, but it doesn't meet the customer needs. It may not actually work in the environment that it needs to work in. You just don't think of all those big picture items. So at TechScale, what we try to do is bring all that experience of nearly 30 years to help people focus, work on the right problems at the right time, reduce technical risk. You can't do it all at once, but what are the big ones we need to do today? What the ones that can wait for 6 months down the road, and try to stage all of that. And that's really what we do here at TechScale. And we've been doing this for a while and had a range of different companies, and it's exciting. A lot of different industries too, so you really get to see a lot of different things.
Fantastic. So you spent over a decade inside of a large company. For privacy's sake, I won't name the company. They can find that on your LinkedIn profile when we connect everyone with you. But big company, you were doing structured design reviews, you were doing formal development programs, and then all of a sudden you kind of went completely opposite end of the spectrum and you started working with a startup that had limited funding. You were trying to help them, get something out the door. And so what I'm wondering is on those two different sides of the spectrum, right? Like, uh, you know, what did that, I guess, whiplash effect between those two different worlds, right? What did that really teach you that you don't think you would have learned if you wouldn't have worked with both of those companies?
Yeah, that's a good question, Alex. I think, working in the large company gives you kind of it's really a training ground of sorts. It gives you a lot of the structure. How do you keep control of, documentation and designs and things of those natures? How do you build supply bases? That's a big part of what we do here at TechScale. Is it's great if you can buy some parts out of, an overnight kind of shipping place, put it all together and see if it works. But in reality, you need reliable suppliers. So starting to develop those relationships. And then when you're getting those parts in, making sure they have the right quality, they got to meet whatever the design intent was for those. And then of course, cost is always a big thing as well for all products. And you start to look at that, and that's something you get out of a big company. They've got good processes for putting that in place because they've got a reputation to uphold and basically to be able to deliver a product. Because this may just be one of many products that they're delivering. You switch to the startup and you have a fixed runway. You have X number of dollars of funding, and you can do the math and figuring out, what is your burn rate and when are you going to run out of money. So that kind of sets the end goal where you have to have something to be able to show to perhaps, raise another round and proceed there. So it creates a sense of urgency, which is really important because, in many industries, not just in the energy and the climate tech areas, speed to market is really important. Getting something out there that people can use right away and getting that feedback early is really important. And that's something we got to see in the startups, in these design reviews and long processes. In a large company, you're moving much slowly. There isn't quite that sense of urgency because they do want to get it perfect, and they have the resources and the means to take a little bit longer to do that. The startup, it's put the duct tape and baling wire on there and get it as good as you can get it and get it out there. One thing we don't take shortcuts on is safety. We make sure the design is appropriate. So there's when you're playing in hard tech, it's different than software. We can't just send out a patch when something fails. We need to physically change a part or make a new component. So there's a little bit more time. It doesn't turn as quickly there, but it's compared to a large company, that turn rate is much quicker. So kind of answer your question, that was the big change I saw between the two. And there are some startups that do take more shortcuts than others, and there's definitely a happy medium there. You don't want to run too fast, get the wrong product out there. I've seen a lot of companies that do the kind of more of the software idea of build it fast, build it again, break it. That's okay, but when you're dealing with hard tech, two problems. One is the fact that's really expensive to do that because you're buying materials, you're making parts to put it all together. The other thing is it actually takes longer in the long run because the cycle times, you need to make some parts. It's not like a software coding that you could run in a day or two. This could take, 6 weeks or even 3 months to get a part. Then you try it, it breaks, and you have to wait another 3 months. So that doesn't work as well. So there's definitely a happy medium. That's what we try to do, is guide people on, what are those paths that make sense to get out there quickly, but not so fast that you actually lose time in the end.
And so when you pivoted to TechScale Solutions and what you guys are doing, I remember you saying something along the lines of one of your goals was to marry the best of both of those worlds that you came from, right? And so digging into that a little bit, from your perspective and as the owner and founder of TechScale Solutions and all the companies you guys are helping, what does the best of both worlds actually look like? I think you just hit on a couple of those points, but
Yeah.
expand on that a little bit for us.
Sure. Yeah, I think, in the large companies, having that rigor of a process of, we're going to start a new product development program today, set those requirements early. What does this product need to do? And also set what does this product not need to do? Because there's a balance of, again, getting back to the continuous iteration, we have to stop at a point and say, that's good enough. But setting that all up front and making sure you've got all that information from your technical team, but also from the other half of the business, which is looking at the sales and the marketing and all the finance side of it, to make sure this all comes together and it makes sense. So getting that all done up front, and then as you go through the process, having those kind of checkpoints that you have a conceptual design review. This is kind of the napkin sketch of what we think we're going to do. Does that make sense? And everybody's weighing in, and you kind of get to the detailed design review. And each time you're getting a little further down the path, but you're also reducing the risks. You're burning that, we call it burning down the risks. So maybe you ran some tests to say that, okay, there's these two different materials. We don't know which one we should use. We're going to try them both. And we realize this material doesn't hold up in the environment. So we're going to take that one away, but now we have this other one. And running those parallel paths is helpful because if we just pick the wrong one first, then we've got to start over again and we lose more time. So those are the types of things in a large company that you want to take into a startup. You go to a startup, what happens a lot of times is you've got, a couple founders. Oftentimes, in my case, they're coming out of university, really smart people, PhD scientists in many cases, that know their details of their whatever their secret sauce is that they're making. It could be a electrochemical process, it could be a new material. They're down at the molecular level trying to think about how to make this even better. But what they're not thinking about is the bigger picture of all the other things you have to worry about that, we learn about in a big company. Like, we have to figure out how to actually design this, how we're going to test it. Do we have the right facilities to test it? Safety is a big one. We're testing some of these could be flammable materials. Is our laboratory properly set up? And if it's not, we're going to bring in someone to help you do that to make sure everybody can be safe in their working environment. And then looking further down the road to the supply and the manufacture and the quality. What I see a lot of times is 3D printing is all the rage. People love 3D printing. You can make anything you can imagine, just about. Sometimes things you can't even machine. So it seems great, but the problem with it oftentimes is that's a one-off kind of production. It's not feasible to make high volume out of it. It's great for a prototype. It may not have the durability of the material you need in that particular environment. So you can prove out a concept. We have to quickly think about what is next. How do I actually manufacture this? And having those relationships with suppliers becomes very important. That these a lot of startups just don't have that capability. So finding the right supply base, and sometimes it's as simple as a machine shop in your local town or city. They've got people that know how to make parts. Engineers are great at making CAD drawings, and then they bring it to a machinist and they say, well, that would be really difficult to make. And you have that conversation back and forth and say, tolerances and things like that, we could simplify that and it would be a good product, as opposed to just sending out a drawing to somewhere, around the world and just getting a part back and hoping that it meets your print, it has the right dimensions and tolerance. So building those relationships early, oftentimes, locally sourcing just to get that quick turn time. Later on, you can figure out, based on the supply and where you're selling and all that, there may be other, larger, higher volume places that you'd want to work with that are going to help you on the cost side. But having that experience in your startup is really important. So it really gets down to the manufacturing, as I mentioned, the design side of it, and then just basically getting that feedback as you get the product out into the market. That's one thing that startups are good at. Getting something out, you get your kind of small scale thing, you make it a little bigger, you do a pilot, you put it out there, you operate it, you learn a lot. I've seen many, many times where you put a product out there and you learn things that you didn't quite expect to learn. For example, it's out in a environment and it's getting, wind or sand or other debris that's getting into an intake on this device or something like that. Maybe we need a filter there. Those kind of things that, you might have been overlooked initially. And in your pristine lab, you never would have discovered because your lab is all set up for just, an optimized test. Getting that out in the field and getting that experience and then learning what to do when it comes back, take it apart and say, okay, well, that didn't work. What can we do to fix it? And that's really what we try to marry together with the big and the small companies, is kind of taking all those different pieces and kind of taking the best of each, but not being too formal with the process, because it can, a lot of startups can't weather that amount of time. It really could take
Right,
years to develop a product.
right. And when I talk with founders and high level thinkers like yourself, I always find that in most cases there's a specific defining moment, or there's something where they identified a gap or a problem that they can solve. And so I'm wondering, for you, was there a specific moment, whether it was working with the startup or working with that larger company you were with, where that you were with, was there a moment where you said, this is the gap that I want to spend my career closing, right? Like, where did you identify that? What really made you pivot and go, hey, this is something that I can help people solve?
Sure. That's an interesting thought. I'm an engineer at heart. I love to solve problems. And I've done that for many years, and coming up with new solutions and designs. But as an engineer, as your career develops, you kind of have two paths you can follow. One is you become we call a subject matter expert, that you are the person people go to for a very specific technology. So maybe you're an expert in metallurgy. You understand an alloy. We're going to go develop a new product that needs a high temperature alloy. This is the person you want to talk to. The other path you could follow is more of kind of the leadership role, where you've got to be able to guide all those subject matter experts to work on the right problems. And I got a little bit of that in my early stage at the larger company, where I was leading a team of engineers and scientists and technicians, and everybody has different abilities and different contributions to the team, and trying to figure out how do you put all that together to get to a point where you can get the job done. So I quickly realized I had a real interest in that side of engineering, is really more the applied side of how do you build the team? How do you get things working together? I went to the startup following that, and it's a small company. There was about 10 to 12 people there, and you could be the VP of engineering, but you're also out back, running wires and setting up control panels and plumbing and testing and going out to customers and putting things in boxes and shipping them too. So you're doing a little bit of all the different roles there. So that was kind of an area where I got to see, a different side of that leadership and really realized that that's, an area that I really enjoy working with is, being a teacher really. I actually go back to my parents originally in their careers, they were teachers. So I kind of got an experience of that early on. And, kind of this is a different application of teaching, but it was engineering where you could actually apply, some knowledge, but actually use it to teach others. And that's really, getting back to the comment you made at the beginning about as a consultant, I'm teaching people to fish basically. And my goal is to work myself out of a job. So really what I'm doing is getting the teams enough ability, get the right people on the team. A lot of times you have those, 3 or 4 expert people that started the company, but they don't have all the skill sets to actually operate the company. So you need, operations people, you need quality control people, you need finance and HR and all those other different areas. So helping to figure out where do you bring those people in and how do you bring them in? Is it always going to be, just go out and hire, 100 people? That's really expensive, takes a long time. Or are there certain pieces where you can actually, use some partial time people, consultants and things like that. Certain other ones where it's maybe, really deep into the technology, you want to hire those people because you want them to be really close to the technology and the team and developing that. So putting all those different pieces together ends up being a kind of an interesting part of it. And what I've found working with, more than 2 dozen startups at this point is that everyone's different. So not only is their technology different, but the team makeup is different. So you kind of get in, assess where people are at, and figure out how you can best add value. And that's really what I try to do. I'm not there to run the company. Everybody knows I'm there as a consultant, so I'm not there to take anybody's job. I'm really there to figure out how to make the people we have most effective, and then figure out where all the gaps are and how do we fill those gaps. And whether it's through hiring or part-time consulting people, bring those types of resources into the company.
And earlier in the conversation, and I've seen this many times being a manufacturing background that I have for 15 years, you made the point, and I've seen it, right? Sometimes you get engineers or you get scientists, they iterate towards perfection, like you said. And sometimes that actually can be the exact problem that you want to avoid, because when you have investors involved, when you may have cash flow issues, or you're a startup, time is of the essence. Money is not something that's just able to be thrown out freely, right? You have, different things that you need to pay attention to depending on where the company's at. So how do you tell the difference between, a risk that's actually going to kill a product or kill a company versus something that's just like, hey, this is a normal engineering problem. We can worry about this down the road or work through it. Like, how do you really separate those two and be able to differentiate, like, what's over iterating and taking engineering too far versus what can we do to get a product out to market?
Yeah, there's definitely, what I see typically is, a lot of times the way these startups come about is there's been an invention, right? They've got some new technology, maybe it's capturing carbon and turning it into jet fuel, or it's doing some other process, and they do it at very small scale. And then it becomes a question you really have to kind of weigh, and some of it just comes from experiences. What's just good engineering process and scaling? So for example, if you've got, something that's running, a liter of liquid through a process and you need to make it, 10 or 100x the size, that's a scaling exercise. There is standardized, methods of calculating, how big should the pipe be and the pressure drop and the pumps and the valves and all those kind of things. That's the type of thing that's not really a risk intensive technology. It's really just we just got to do the work type of thing. And you can set up, when that needs to be done and find the right people that can do that. Where we get a little nervous is when, the product, maybe it's working, but it's only lasting for hours and it needs to last for years. So that's a problem, right? You can't move forward until you figure out, what is the root cause of that. So we spend a lot of time, doing things like root cause analysis, where you really want to get to the heart of, why is this failing? And oftentimes it's, it could be a combination of events, but also times it could just be we have to change the way we operate this. Maybe if we shut it down without purging, or we do something that damages the material. So let's change our systems model and operate it differently. So doing a lot of that work up front helps us understand that the thing is working. And that's really the first step. The rest of it and I rely on the team for quite a bit of that. I'm able to, quickly kind of assess the technology and understand it from background of other similar kinds of projects, know where to look for the problems. But I'm really going to be leaning on the experts, just as we're talking about subject matter experts, to find the solution to that problem. Is it a new material? Is it a new operating condition? Is it a new way of putting these parts together, perhaps? So those are all things that we try to look at. When we get to the stage of, okay, now this thing is working in the lab and now it's scaling, finding a supplier isn't, it's definitely a risk. You want to pick the right suppliers and you want to ideally have more than one. So if you have a supply chain, issue both for cost and for reliability, but those are things that people know how to do.
Had a little technical difficulty, but we're back with George Roberts. We were talking through some things, and I want to get into really what George specializes in, which is turning prototypes into products for companies. And so you had talked about, we talked a little bit about iterations and how you got to be careful on what's actually a company killer or a product killer, and what we're able to just move forward with and engineer a solution as we bring the product to market. And so getting into turning prototypes into products, you had talked about sometimes you don't want to wait too long for perfection, and that can actually be a problem for a company because it can cost them money and time. And so we were getting into how do you tell the difference between a risk that's actually a product killer versus something that's just a normal engineering problem that you can work through. So let's continue on that point.
Yeah, so I think that basically, a lot of companies start out with an invention. That's kind of their starting point. They've got something that's unique and they're going to move it forward. As we start to go through that, we're trying to understand, how robust is that invention? Is there things we've missed in there? Is there, does it actually operate, for the performance we need, the lifetime we need? And those are the areas we spend a lot of time on initially, making sure this thing actually works. And of course, there's the freedom to practice on the intellectual property side and other things we have to consider. But getting back to the technical side and the risk, we spend a lot of time in that first spot, just making sure that, when we get those early failures, why did it fail? And doing things called root cause analysis, really getting to the bottom of why did this fail? How do we fix this? And sometimes it could be multiple different variables that are coming in, or sometimes it could be we need a different material or we need to change an operating condition. So working through a lot of those things early on are very critical. I have had clients I've worked with where we've looked at it and technically the thing actually worked. And so that's great. But then we do the math and the techno-economic analysis and realize that it doesn't make sense. You can put energy in and you get, less out on the other side. So it's not really, the efficiencies don't pan out. There's better technologies in that area. You kill a project. And we've done that before. But on the getting back to the technical side, if it is looking good, then we can continue to keep moving it forward and assess those risks and really start to move into things that are more predictable. So, as you start to get into, as we talk about, we have a prototype. How do you make it into a product? Okay, now we need to scale it up. It needs to get, X number of times larger to fit this application. As I mentioned earlier, there's things you could do with, they're just good engineering rules of thumb and how you scale things, and there's calculations and formulas to do all that. But there's other things that we have to watch out for along the way. And those are there showstoppers? And the one I see quite often in my world is the durability of the product, because you can imagine that, a product that needs to last out in the field, generating whatever it's making for years of service. If it's lasting, a day in the lab, well, that's a long jump to get to years of service. So let's understand where that gap is. And also lay out, what makes sense, because you want to get that product out there. And some say maybe it's you can't test for 10 years and see if it's going to work and then get it out. You missed the market probably. So we look at things like accelerated tests. An example of a drive cycle on a hybrid vehicle or something. You're going to drive it hard. Turn on, turn it off, simulate a load cycle that it would actually see. Maybe it's running at higher temperatures or more tougher conditions, and you can try to make that go more quickly so you can see the failure modes more quickly. The other thing you can start to do is to project out, what that lifetime is. And you may even get to the stage you're comfortable. Okay, we're going to put the pilot out, and we know it's not going to last 10 years, but we think it's going to last 3 months. And we know when in 3 months, these are the parts that are going to fail. We'll swap them out and we'll keep testing. And then that product, we at least have tested all the other parts of that system. And in the meantime, we've got a team that's working on those parts to figure out, why are those failing? And let's make those more robust. So in the future, that thing doesn't last 3 months, it lasts, 3 years or more, that type of thing. So trying to break it down into smaller problems and figure out, what are the showstoppers versus what are the things that we have to keep moving forward because there's other things we don't know yet. And to try to figure out those unknowns, we could sit here all day in a conference room and talk about it, but sometimes getting it out there, finding out the hard way, and then making that change makes it happen much more quickly.
So beyond the bringing prototypes to product, right? We obviously know you have a wealth of experience with engineering and you understand that side of it. But something else that I found interesting about what you do at TechScale Solutions is you actually bring in a team. You have a really good network of people, whether it's engineering, manufacturing, legal, sourcing, compliance. Those are just some of the things I remember you touching on. And you bring in people as needed, right? So really you're a connector. You're not necessarily bringing in employees, but you're connecting them with the right.
So there's definitely, we have the engineering side, but there's also, how do you manufacture this product and where do you buy the parts for this product? How are you going to actually put it together? Are you going to build yourself a factory? You're going to work with somebody else. So trying to assess those things early on to figure out, a lot of times there's intellectual property. Maybe you want to make that piece within your own walls, but you want to buy panels and controls and cabinets and things like electrical components. You can have someone else make that for you. So trying to put those relationships together and get people working on what they're good at because the guys down at the molecular level, they're figuring out their secret sauce, but they don't need to be the guys that are wiring an electric panel for a control system or something like that. There's plenty of people in the world that know that much better and much more efficient at it. So working through all those areas are important. Figuring out where do you bring those in. So planning, because it takes long times to actually execute some of these things. So figuring out when do you, if you are going to build a factory, you better start, way in advance because it's going to cost a lot of money and there's a lot of, you got to find a site and you got to buy the equipment and get it all up and running. So there's that direction, or you at least put together a plan and say, okay, initially we're going to go to a contract manufacturer, and then perhaps maybe later when the volume gets to X, then we expand and we either add another manufacturer or we build our factory. Having those different plans in place is helpful for not only the founders of the startup, but also their boards, their investors to see, where are those trip points where there's decisions to be made without, just saying we're going to go out, spend a ton of money, build the whole infrastructure and hope it all works. You kind of want to do it more incrementally. So there's there's the manufacturing side, there's the supply base, as I talked about earlier. A lot of these components, if it's just standard off the shelf parts, that's fine. You can source them from multiple sources. But if it's something that's custom made for your company, you want to have a good relationship with that supplier. So getting those relationships established early is important. So that way you can be confident they're sending you the right parts and they're the right quality and they can keep up with your demand. They have visibility into what your growth plan is. So starting to think about volumes and those type of things. Then there's all the other skill sets too. I mean, operations is important. That kind of gets into this whole side we just talked about of supply chain and manufacturing. There's intellectual property and legal, trying to figure out, A, do you have freedom to practice what you're doing? It's not infringing on someone else's intellectual property because you don't want to go down the path, launch the product and find out that you can't actually sell it. So get that out of the way very early on so we make sure they're at least working with the right people. I'm not an expert, I'm not an attorney, but we work with people that understand that very well. The other areas are even things, such as, human resources and some of the other parts of the business and finance and, ultimately marketing. And what I do typically is, again, I'm not hiring these people directly. I'm identifying the need for these, hoping to, make that connection to the company and to these people, either through full-time or through consulting roles, and then letting them kind of move forward with that and, kind of guiding to make sure that all the bases are being covered, if you will. We're making sure that there's continuity and it's growing at the right rate. So we don't get in a situation that, the company has grown so much, but we can't keep up with it. And, one last thing I would just say that's of an interesting point that I've always run into is as the company grows, communication changes. And, one thing I've often seen is when it's, six people in a laboratory, they walk around, they talk all day long, and they kind of know what everybody's working on. As the company grows, everybody still wants to know what everybody's working on, and it becomes impractical because there's just too many things going on. So trying to figure out how do you kind of segment the different groups, but to still keep the culture of the company. And that's a piece that oftentimes gets forgotten, but it's still a big piece of it is trying to figure out, what is the mission of the company? Why are we doing this product that we're working on? And then why does it matter? And how do we make sure everybody actually enjoys coming to work and doing their job and contributing to the company? So those are all the softer sides of things that are not really, hard tech engineering, but they're really important because you can have the best science, but if you don't put all those other pieces around it, it'll never go anywhere.
Right. And I think that's where your experience brings that all together, being that you've managed teams like that, you've been a part of different size companies. Um, you've been doing this for quite some time, right? Since 2014. And the business climate has changed. It's changing more rapidly every year, I feel like. And so one question I do have is what have you noticed, the difference between when companies used to come to you and the problems and the things they would be trying to solve versus today, or 5 or 6 years ago? Like, what are the differences in when you started out doing this, the problems companies faced, and some of the newer problems and challenges that you're helping companies solve?
Yeah, I mean, working specifically, referencing the climate tech industry and renewable energy, and that's where we spend a lot of our time. It changes over time, and looking at funding and financing for a lot of these different projects, and it's hard to if you have a known technology, if you want to put in you've got an AI data center, you need more power, you can go buy a gas turbine and you can size it, and there's a price for it. It's all pretty well understood. It takes a long time to get it in, but there's a path for that, and there's a way to finance that. In a lot of these other markets, these could be equally useful products, but it's hard. They haven't been proven out in the field. There isn't a standard product yet. There isn't the lifetime, so it becomes hard. It's not real bankable yet. It's hard to get financing for that. So earlier on, you would, and it kind of goes through cycles. I've been, as I said, I've been doing this at some level, TechScale for 12 years since 2014, but then before that with other companies. And there's always these different cycles of time where there's, more emphasis put on, different climate technologies and less, and that it comes back and forth. And I think, we all understand that there's no one size fits all, that there's going to be the magic bullet that solves all the energy crisis. We actually need more energy now than we've ever needed. It's getting more. The entire globe is getting more electrified. So there's always going to be need for more energy. So thinking about, what are the ways you can solve it? And there's probably an infinite number of solutions to that problem. And then trying to put all those different technologies in place and figuring out, which ones have the best path moving forward. And those are the ones ultimately that will get, a little bit more attention, a little bit more funding, and then move forward. So, so kind of getting back to your question, what have I seen from, let's say, 10 years ago to now, is really a focus on the execution side, because what has happened earlier on was, people are trying things, putting them out in the field, they don't work, and then the company just goes away. And there's plenty of those stories. For every startup that makes it, there's hundreds that don't make it. So, there's definitely a little bit, both the investment community and the general public have gotten, very educated on the fact that let's really ask the hard questions. Is this product that you're making going to solve a problem? Is it economically viable? Because you can have the best mousetrap, but if it's more expensive than the other mousetrap, it doesn't. It's no one's going to buy it. So understanding those different limits and thinking more broadly, and that's really what I've tried to bring to the table, is looking at that big picture and figuring out where does this fit in the grand scheme of things, because then you can go talk with investors and explain the value proposition and explain the actual marketing plan of we can see selling X number of units this year and 10x 5 years out or something like that. Before, people would have these crazy, we call them hockey stick, types of growth rates, where we're going to sell 10 this year, we're going to sell 100 next year, we're going to sell 1,000 the next year. Well, really, that's probably not going to happen. So let's be more realistic. Let's kind of, put these together and think about what that will look like.
I know we have a lot of people in the audience and a lot of people that listen that are in the manufacturing space. They're in the prototype space. I think I told you, I actually worked for a 3D printing company where we did a lot of prototyping, like you're talking about. And I think what you do is you bridge that gap from the engineering side and someone having a brilliant idea, and you work with, like you said, you have brilliant engineers and people coming out of university with these ideas, and you bridge that gap to actually bring that product to life. So as we close out, I want to give you the opportunity. Where is the best place to find TechScale Solution? What's the best way to connect with you for people that are looking for your services? Just give us a little bit more about where we can find TechScale and connect with you,
Sure.
George.
Yeah, so you can see my website's down in the bottom corner, techscalesolutions.com. That's a good place to go to get kind of an overview and the email contact information. You can find us on LinkedIn and other social platforms. And I think as you look on our website, you'll see things like our process development, our product development process, I should say. Kind of the stepwise approach that we take. But I think the one thing I would say is that unlike a large consulting company, what we're a little bit different on is by being more nimble and small, we're able to adapt to the specific needs of a specific startup. As I mentioned earlier, everybody has a different culture, a different time horizon, different levels of funding, and really adapting to get the best value for that particular application is really what we focus on. So there isn't just a playbook that we just run every time. That's the same thing and just rinse and repeat. It really ends up being getting involved. And we really like to be at least as often as possible boots on the ground with the team, embedded with the team. And we're all over the country, so we're both from the West Coast we're here on the East Coast of the United States, and getting involved and really understanding the team. So it's one thing to understand the technology, but also to understand the dynamics of who does what, who are the technical experts here, where are the gaps, and helping to really coach and mentor at that level. So you'll see a lot of that if you go on our website. There's some kind of summary pages that talk about the services we offer. It's different services when you get to a Fortune 500 company. We work with them as well, and that's a much more focused project. We've got a problem, help us solve it. We already have the big infrastructure behind them. The startups are a little bit different depending upon where they are. They may still be trying to raise an initial seed round. So maybe we're just putting together enough information to help them get a roadmap of their product and where they're going to go with it, so they can go out and do a pitch and say, here's how much money we need, and we've been able to estimate it, and here's what you're going to get at the end of this, and then here's what we would need if we continue beyond that. So those are the types of things that we end up helping kind of different realms there of kind of maturity of companies.
Wonderful. Well, what we'll do is we will make sure that we put George's info in the description of the episode. We'll make sure we put the website. I'm also connect with you on LinkedIn, so we'll put your LinkedIn profile there so that our listeners can connect and follow and check out what you guys are doing at TechScale Solutions. Again, this is George Roberts with TechScale Solutions. You can find them at techscalesolutions.com. All that will be in the description of the episode. We have a tradition on the podcast, George, because we have a lot of fellow entrepreneurs and business owners that listen. And so it's called the magic wand question. And so how I end the podcast is I like to ask, because being a business owner isn't always rainbows and butterflies and not so cloudy skies and sunshine, right? And so the question that I ask at the end of every episode to help people is, if you had a magic wand that could fix one thing in your business right now, what would that be?
Yeah, that's an interesting question. I think the first thing that comes to mind is really trying to have a level loaded amount of work, I guess I would say. Really, when you think about it as a consultant, it's a little bit like farming sometimes. You have strong years where you're out there, got more crops than you can possibly handle, and then other years where the weather's not so good and you're not able to keep up as much. And what we find typically is that there's as a consultant, what you end up doing quite a bit is you're working very hard for your current clients, but you always have to be thinking about what's down the road. As I mentioned, some of my clients, typical engagement can be anywhere from 6 months to a couple of years. Is kind of the range that we're in, and you'll have a bunch of several clients at any given point. So the magic one would be to be able to evenly space those out and know which ones are coming off, at the end of a certain time period, which ones you can roll in at that time, and having them ready, because oftentimes there's always that mismatch of, well, we want to work with you, but the funding isn't here yet, so let's stand by for that, and we'll do that quite often, and come back to them later. But getting that schedule, it's really a scheduling challenge. Is trying to make sure you're fully utilized and not oversubscribed either.
Awesome. Well, thank you for sharing that. Again, everybody, today our guest was George Roberts from TechScale Solutions. Again, this is Alex Durante, host of the Grid Shift podcast. George, thank you so much for being on. I really appreciate your time. And if there's anything else you want to say to close us out, otherwise we'll make sure we have your bio and everything about your company in the description, and we'll start getting people connected with you at TechScale Solutions. So thank you, George.
Great. Thanks so much, Alex. I really appreciate the opportunity to talk with you today, and look forward to further connections in the future.
All right, sounds great. Thanks, George. All right, guys, we'll see you next time on the next episode of the Grid Shift podcast. Thanks, everybody.